okay, some of the related videos that would help us in our lecture. Okay, a moment. So this is just a review on some of the concepts, and later on we'll have an actual computation calculation. So itong tatlong topics na to, it's actually gonna be good for a week, and then it's gonna cover also the laboratory experiments that we'll be having. So it's just gonna be an online simulation. It's not an actual yet. Kasi nung na-realize ko because of the current call this yung presyo ng gulay, parang wala yata akong nakikitang red cabbage ngayon. Eh, kailangan natin yun for our actual laboratory at home. So far, wala akong nakita sa may area namin. So, malamang wala siyang supply ngayon. So, yun ang gagamitin natin sana. Okay, so wait lang. Let me just go to the videos. Wait. Ito muna.
Hey, it's Professor Dave. Let's look at chemical equilibria.
He knows a lot about the science stuff. Professor Dave explains.
Sometimes chemical reactions are not unidirectional. They are reversible. The reactants create the product, which then go right back and create reactants. This means there is both a forward and a reverse reaction. When the rates of the forward and reverse reactions are the same, this system is at dynamic equilibrium. Chemistry is happening, but because the reactions are happening at the same rate, there doesn't appear to be any activity. There is a balance. We learned how to use stoichiometry to discuss limiting reagents and how much of the products to expect. But these were for unidirectional reactions where we assume that all the reactants make products and then the reaction is over. With equilibria, it's a little more complicated to calculate what the concentrations of each substance will be at equilibrium. So we're going to have to do a little bit of math to be able to describe the system. For example, let's look at this equilibrium. Let's say we start with 1 mole of PCl5, allow the system to reach equilibrium, and then once at equilibrium, we measure that there are 0.135 moles of PCl3. So how much of the other two things are there? To answer this, we can make something called an ice box. These letters stand for initial, change, and equilibrium. We set them up like this. For initial, we put the initial amounts of each thing. We started with just 1 mole of reactant, so we put 1 there and zeros for the products, since there wasn't any of those at first. Then for the change, we don't know exactly how much the change was to get to equilibrium, so we call it X. For the reactant, we put negative X because it is being depleted. And in this case, all of the stoichiometric coefficients are 1, so as X moles of reactant are being depleted, X moles of each product are being formed. We would make these 2 or 3X as necessary if the coefficients were different. And for the products, X is positive because these are being formed. Then lastly, we add up the initial and the change to give the amounts present at equilibrium. For the reactant, this is 1 minus X, and for the products, it's simply X. We measured the final concentration of PCl3 as 0.135 moles, which here will correspond to X, and we therefore know all the other concentrations by plugging in X. Simple, no? Well, it can get trickier, as we will see. But first, let's learn about equilibrium expressions. Every equilibrium has an equilibrium constant, Kc. It will be given by the concentrations of the products, each raised to the power of their stoichiometric coefficients, over the concentration of the reactants, each raised to the power of their stoichiometric coefficients. This is called the equilibrium constant expression. One thing this constant tells us is whether the products or reactants are favored in the equilibrium. If Kc is much greater than 1, that means the numerator is bigger, so we are creating more products. If Kc is much less than 1, that means the denominator is bigger and we are creating more reactants. When we write this expression, we only take into account gases and aqueous species. Solids and pure liquids will not be included in the expression. For example, here, notice how carbon is not included in the expression, since it doesn't make sense to discuss a solid in terms of a concentration. Sometimes we may want to predict which way a mixture will go given some non-equilibrium quantities. To do this, we plug the non-equilibrium values into the Kc expression to calculate the reaction quotient Q. If Kc is bigger than Q, Q is more on the reactant side, so it'll make more products to equilibrate. If Kc is smaller than Q, Q is more on the products side, so it'll make more reactants to equilibrate. When Kc equals Q, the system is at equilibrium. Let's try a more difficult icebox. Given the following information, calculate the equilibrium concentrations of each substance in terms of molarity. Remember that molarity is moles per liter. So we set up our icebox and calculate the concentration of our reactant. That'll be the initial value, and 0 for the products. Now here, the change will be different for each substance because of the stoichiometry. For every 2 moles of reactant, we get 1 mole of each product, so we have to subtract 2x here and add x here. Then equilibrium is just the sum of initial and change. Plug them into the equilibrium expression and solve for x. Luckily, on the right, both the numerator and denominator are squared, so we can take the square root of both sides. If it wasn't this convenient, we may have had to use the quadratic equation. But as is, we can solve for x and use that to determine all the equilibrium concentrations. Let's check comprehension.
Okay, I'm not gonna be asking you to do this part. I'm just the reason why I included this in the presentation is that it would be helpful for us in terms of doing chemical equilibria. So let me just go to the next video. At least marunong kayo produce ng equilibrium constants, which will be needed when we go to the pH buffer systems. Okay, so I need to establish that. Although I know some of you already had background in chemistry, this is actually part of the Chatelier's principle about equilibrium.
Hey, it's Professor Dave. Let's talk about acids and bases.
He knows a lot about the science stuff. Professor Dave explains.
We've probably all heard the terms acid and base, but what do these words mean on the molecular level? Let's discuss the rigid definition according to a few different models. Most often, when we talk about acids and bases, we are referring to the Bronsted-Lowry definition. According to this model, an acid is something that donates a proton, and a base is something that accepts a proton. An H+ ion is a proton, because if a hydrogen atom loses an electron, all that is left is the proton that comprises the nucleus. Proton transfer is a big part of chemistry. An acid and base will react to form a conjugate acid-base pair. The thing that gives up a proton is the acid, the thing that accepts it is the base, and on the product side, the base has become the conjugate acid, and the acid has become the conjugate base, because the thing that gained the proton could potentially lose it again, acting as an acid, and the thing that lost the proton might gain it back, acting as a base. The Bronsted-Lowry definition only applies to protic species, or molecules with hydrogen atoms that can be lost as protons. But there are aprotic species that also display acidity and basicity. This is what the Lewis definition entails. Under the Lewis definition, a base is something that donates a pair of electrons, and an acid is something that accepts electrons. A Lewis base is indistinguishable from a Bronsted-Lowry base, but the acids differ in the sense that a Bronsted-Lowry acid must have at least one hydrogen atom. A Lewis acid just needs some partially positive atom. A species that can act as both a Bronsted-Lowry acid and base is said to be amphoteric. Water is amphoteric because it can behave as an acid, losing a proton to become hydroxide, or it can act as a base, gaining a proton to become a hydronium ion. In a sample of water, a tiny fraction of molecules transfer a proton from one to another, which we call an acid-base reaction. This is an equilibrium and is shown here. We can write an equilibrium expression by showing the concentrations of the products over the concentrations of the reactants. We will only include gases and aqueous substances, so here it will look like this. At room temperature, this equals 1 times 10 to the negative 14, or 1/100 trillionth. That's the fraction of water molecules that are ionized at any moment. As temperature increases, Kw increases. Hydronium concentration, which is essentially proton concentration, if above 1 times 10 to the negative 7, gives an acidic solution. If below, it's basic. If equal, it's neutral. When looking at conjugate acid-base pairs, we must understand that a strong acid is something that will very readily lose a proton. If something is a strong acid, it means its conjugate base is very stable. That's why it's so willing to lose a proton. A strong acid will have a weak conjugate base, since the conjugate base will be very stable, meaning it isn't dying to pick up a proton. A weak acid, something that isn't very willing to lose a proton, will have a strong conjugate base, something that will very easily gain a proton. So if the strength of an acid is proportional to the stability of the conjugate base, we have to be able to predict the stability of conjugate bases in order to tell how strong an acid will be. Whichever atom is losing a proton, the larger it is, the more stable the conjugate base will be. Comparing the acids made by combining a hydrogen with a halogen, we can see that Hi is the strongest. This is because when the proton leaves, we are left with an iodide ion. This is much larger than a fluoride ion and therefore can diffuse the negative charge around a greater volume, thereby stabilizing itself. Fluoride is much smaller with a very localized charge and is therefore less stable. So hydrofluoric acid is a much weaker acid than hydroiodic. Also, the more electronegative an atom, the better it is at accommodating a negative charge. So an oxygen atom can more readily lose a proton than a carbon atom, which is why something like water is far more acidic than, say, methane. Acids are also stronger when their conjugate bases are resonance stabilized. A carboxylic acid is about 1 trillion times stronger an acid than water, even though both of them leave an oxyanion after deprotonating. This is because the conjugate base of the carboxylic acid can share the burden of the negative charge between two oxygen atoms by resonance, while hydroxide can't. These resonance structures don't actually exist, but rather the composite resonance structure does, which shows delocalized pi electron density distributed about this portion of the molecule. More on this in organic chemistry. There can be monoprotic acids, which can only lose one proton, or polyprotic acids, which can lose several. Polyprotic acids become less acidic with each deprotonation. In an acid-base equilibrium, the side with the weaker acid-base pair will always be favored. This is because the stronger acid or base will have a greater tendency to react and generate the weaker species. We can tell acid strength by looking at an acid's pKa. The lower the pKa, the stronger the acid. Strong acids deprotonate completely, transferring every acidic proton to molecules of solvent or other things in solution. Weak acids only deprotonate partially, generating some of the conjugate acid, but won't react completely. The weaker they are, the less completely they will react. Once again, the hydronium concentration measures the degree to which an acid transfers protons to water molecules, and therefore the strength of the acid. But hydronium concentrations have inconvenient exponents, which can be cumbersome to list. So we have developed a more convenient way to describe acidity. The pH of a solution is the negative log of the hydronium concentration. Logarithms are the inverse operations of exponents, so the reason why a negative log is useful here is that it takes an annoying number like 10 to the negative 7 and it turns it into 7, which is much tidier. So a solution with a pH of 7 has a hydronium concentration that is considered neutral. We can also measure the basicity of a solution by calculating the pOH. This is because a strong base will generate hydroxide ions in aqueous solution by stealing protons from water molecules. Just like pH, pOH is the negative log of the hydroxide concentration. Another way to calculate pH and pOH is by using the formula for Kw. From this, we see that pH plus pOH must equal 14. Between these relationships, we can relate pH, pOH, hydronium concentration, and hydroxide concentration, and we should be able to get from one to any of the others using this chart. Let's check comprehension. Thanks for watching, guys. Subscribe to my channel for more tutorials.
Okay, the last video.
Professor Dave here. Let's discuss acid-base equilibria.
He knows a lot about the science stuff. Professor Dave explains.
When a strong acid or base reacts with water, we can say that it completely ionizes, or that every molecule of acid will transfer its acidic proton to a water molecule. If every molecule reacts to completion, this makes things neat and tidy. But when weak acids and bases react, they only partially ionize, and they establish an equilibrium between the ionized and unionized form. And that means we have to do some math. Ka is the acid ionization constant. This is derived just like we got Kc for generic chemical equilibria. Note that we don't include water as it's a pure liquid. In this way, Ka is a measure of how thoroughly an acid-base reaction proceeds in the forward direction. A larger Ka means more products and a stronger acid. A smaller Ka means more reactants and a weaker acid. So an acid with a larger Ka will be more acidic and therefore associated with a lower pH. We can determine Ka experimentally. Let's say we want to know the Ka for a weak acid like phenol. We can set up an icebox just like the kind we already know. We can use the pH to calculate hydronium concentration and therefore also the concentration of the conjugate base, since they are the same. As it happens, the change in initial concentration of the acid is so small that it's negligible, and we treat things as though none got used up. Plug these values into the expression and solve for Ka. From this information, we can also calculate the degree of ionization, which is the ratio of ionized to unionized acid molecules in solution, or the percent ionization, which is the same thing but expressed as a percentage. This is a pretty weak acid, considering so few molecules transferred a proton to a water molecule. Sometimes, like in the previous example, the acid is so weak that we pretend the concentration of the acid doesn't change. But if it's a little stronger than that, we can't make that simplifying assumption, and the math gets trickier, but still essentially the same. We can make ice boxes for weak bases as well, or multiple ice boxes for polyprotic acids, one per ionization, just more math. A buffer is a solution that has the ability to resist changes in pH when limited amounts of acid or base are added to it. Buffers are made by combining a weak acid or base with its conjugate. In such a solution, because both the acid and conjugate base are present, they are able to neutralize small amounts of any acid or base that are added to the solution. Many biological fluids are buffer solutions because they must maintain a steady pH to avoid loss of critical biological function. The bloodstream, for example, maintains a pH of around 7.4. Otherwise, its capacity to carry oxygen around the body would be lost. Buffer solutions of a particular pH can be prepared using the Henderson-Hasselbalch equation. We know about pH, and pKa is similar in that if pH is the negative log of the hydronium concentration, pKa is the negative log of the Ka for that acid. What this shows us is that in order to create a buffer solution of a desired pH, we must use an acid conjugate base pair where the Ka is approximately equal to the desired hydronium concentration, or rather where the pKa is equal to the pH. Let's check comprehension. Thanks for watching, guys. Subscribe to my channel for more tutorials.
Okay, that is for Professor Dave. So let's start with the discussion. Teka lang ha. Okay, I hope you can see my screen now. Thank you. Okay, so this is although you already watched the presentation or the video that was made by Professor Dave, we're just gonna be going into the details that we're not, although it was mentioned, but somehow we need to expound on that one also. Okay, so remember when you talk about chemical reaction, usually chemicals or compounds are usually combined together and either they create or destroy substances in the process. Now, usually it undergoes what we call a chemical reaction. So, in the example that we have here, we have hydrogen gases and oxygen gases. And with electricity, actually kulang yan, dapat nilagyan pa ng electricity dyan, it will form now water, liquid water. Okay? Now, let's just have a recall of the components of a reaction. So first and foremost, you have what we call the reactants and then the products. Now, the reactants are usually the ones that are being utilized to form the products. Okay, so usually you break bonds, you mix them up together to form the new products there. And usually you have what we call an arrow that shows the direction of the reaction. Okay, so for this one, reactants yields products. Okay. Now we also have symbologies that are included in a chemical reaction that states its state. So you have a solid, S, liquid, gas. Then you have also what we call aqueous. So when you say aqueous, you have there a substance that is dissolved in water. So for example, you do not say, pag sinabi mo salt solution, it's an aqueous solution. Okay? So kasi meron kang salt, which is a solid, then it's combined with water. Okay? And then you have also what we call the plus signs if you have more than one reagents or product. And then, as you mentioned already, the yield. Now, in terms of reactions, we also have different ways to identify if a reaction is happening. Okay, so unang-una, if there is an evolution of light and heat. Okay, so yan yung unang-unang, yes, Isaiah? Hindi ako
Ma'am,
narinig.
excuse me po. Ano po, medyo mahina po kasi yung audio.
Wait lang guys.
Kaya hindi po ganun naririnig yung sinasabi. Thank you po.
Okay. Eto, tinig na ba?
Opo, kanina po kasi mahina. Thank you po.
Pero ito, okay na to?
Opo, malakas na.
Okay, thank you. Okay, so going back to that one, so if there is heat and light or light is being produced, there is already a chemical reaction happening, okay? And then another one, wait. And then, of course, temperature change in the environment. So for example, for those who did their laundry over the weekend, if in case you're using soap, usually what would happen is if the soap is very, very strong, you will see a change in the temperature on the water na ginagamitan. For example, naglagay kayo ng konting Clorox, it will tend to heat up on that particular area na nilagyan ninyo. Okay? Then the third one, you have the formation of bubbles or an odor. Okay? And then another one is there is a change in color, especially if there is new substances that are formed. So in the example that we have here, we have rust as an effect of the reaction between the water vapor in the atmosphere and the iron. Okay? And then formation of precipitate or formation of new solids from the reaction of two aqueous substances. Okay? So you have there, if I'm not mistaken, this is tin hydroxide and sulfuric acid. When you form together, you have tin sulfate. Yan yung yellowish color. Okay? So yan. Now, usually equations are written out in this format. You have here the name of the element or the compound, the state it is, and then the yield or the arrow symbol, then the product, and then the state. Now, we will not be going through the different types of reactions. Hindi na po kasi diniscuss yun na yan noong senior high at saka noong junior high. Okay, so this is just a recall para at least mas madali natin matap or makatch yung mismong lecture na dapat natin. Okay, kasi ang pinaka-major focus natin is yung pH and the buffer system. Now, before we go to that one, I need to build up with the lecture muna. Okay, so going back to this one. So if you're going to read this, you're just going to say, you're going to be reading it as mentioned here. So solid iron and chlorine gas will react or combine to form iron 3 chloride. Or a solid will produce a precipitate, or it will produce a solid or a salt of iron 3 chloride. So that's how you usually say it in terms of compounds. Now, we also have what we call a skeleton equation. So a skeleton equation is actually showing the whole equation in terms of chemical formulas. And then you also still going to be seeing the state of the element that is in. So as you see here, you have FeS, so iron solid, okay, and then chlorine Cl2, which is a gas, and then FeCl3, which is the salt, and it is in a solid state. Okay. Now, please take note that this, when you see or when you find a skeleton equation, it's not going to be 100% balance. Okay? So to balance that, you have to place coefficients. Now, in an equation, okay, so you will see these numbers that are included in your equations. Una, you have the subscript and the coefficient. So the one that we have here now is already balanced. So if you're going to count the number of atoms, you have to consider the number of the atoms of each element and how many coefficients. When we say coefficients, these are the numbers that represents your mole or your compound. How many compounds are present? Okay. So the rules in counting atoms is the first one, coefficients propagate to the right through the entire compound, whether or not parentheses are present. Okay. Second, subscripts only affect the element to the left of the subscript unless it is mentioned there or unless there are some things that are included or mentioned. Then third one, if a subscript occurs on the right of the parentheses, the subscript propagates the left through the parentheses. And fourth, when a coefficient and subscript meet, you must multiply the two. Okay? So here, so kung kanina, babalikan natin, okay? So here you have how many oxygen on this compound. So given that we have a subscript of 2, therefore you have 2 atoms of oxygen here. Okay? Now, wala po siya dito. Therefore, isa lang yung 10 natin. Okay? And then here, may coefficient tayo. So, ibig sabihin, lahat for this one, okay, everything that is included, hindi pala nakikita, wait lang. Let me just include my laser pointer. Okay. So here, the number 2 here is actually going to multiply whatever the components inside here. So, di ba, dalawa yung hydrogen because of the subscript times 2, you'll be having 4 hydrogen. Okay? So, ganun din dito. Okay, walang problema si tin sa product kasi isa lang naman siya. Wala siyang subscript, wala siyang coefficient. But on the other one, which is on water, lahat ngayon, as mentioned on the fourth rule, is that whatever is written here, lahat na nandito is going to be multiplied with the coefficient. So, kanina, dalawang hydrogen times 2 gives you 4 hydrogen, and then isang oxygen times 2 gives you 2 oxygen. So that's how you read it out. Okay? So let me just go to the next sample. Wait lang ha. So far, nakakahabol naman po.
Yes po, ma'am.
Okay. Okay. So here is another example wherein you're seeing the coefficients and the subscripts. So here you will notice you have here 6 Fe2O3, then 3 Na2O, and then 2 Fe. So if you're going to read this equation, these are actually the sample scripts that were given. Okay, so 6 atoms. Since it is an element only, so you can say it's an atom, or you can use 6 moles. So ibig sabihin nito, isang molecule na to, isang buong compound or isang material na siya. So we can use 6 atoms of sodium metal and iron oxide or iron 3 oxide, okay? Or 1 mole of iron oxide kasi wala na po siyang coefficient dito. So pag walang coefficient, understood na isa lang siya. So 1 mole of iron oxide will give you or will yield to 3 moles of sodium oxide, okay? Plus 2 moles or 2 atoms of iron. Okay, so that's how you're going to read this expression. Now, take note, it's not going to be in terms of grams. It's always in terms of particles, atoms, or moles. Okay? Pero mas malimit ginagamit po is moles in terms of expression. So, let's have an example here. Okay? So, you have here sodium metal plus water will give you a very explosive reaction. Okay? Alam mo yun, matalsikan lang si sodium metal, pumuputok yan. Okay, will give you sodium hydroxide and hydrogen. So let's have some people, given the example that we have, how many atoms of sodium are in each? So you have, see, Isaiah, in the reactant.
Yung sodium po, 2 po. 2 moles po.
Okay, 2 atoms in each mole. Take note, number 1, how many atoms of sodium are in each mole in the reactant?
I mean 2 atoms po na sodium.
May subscript ba tayo dito?
Hindi pa po i-consider coefficient. So 1 lang po.
Oo, yon. Take note guys that there are terms here that's gonna be tricky. Thank you. Pag sinabing each mole, hindi nyo muna i-consider dito. Okay? So, wait lang. So yan. Na pag sinabing how many moles are there, saka nyo ngayon sasabihin yung dalawa dito. Okay? So yan yon. Pag sinabi namang how many atoms are in the reactant or how many sodiums are there in the reactant, saka nyo ngayon i-consider yung buong yon. Okay? So the next one here, so pag sinabing Miss Medina, kanina may nag-raise ng hand, tama ba?
Yes, ma'am.
Okay. So how many moles of sodium are there in the reactant na?
2 po.
Okay,
2
so yun
moles.
yung 2 moles. Okay. Now, let's have Miss Postanes, Marian. How many
Yes,
water atoms of water are in each mole of the reactant?
In each mole po, meron pong 2 atoms ng hydrogen at saka 1 atom ng oxygen.
Is that the question? Remember, we're talking about water. Bakit iniwalay mo? Ilang water ang meron tayo?
1 lang po.
Yon ang sagot. Okay, so 1. I did not specify kung ilan yung hydrogen, ilan yung oxygen. I'm asking for the compound to water. So medyo tricky again, so ingat-ingat. Okay? Okay, next is Holden.
How many
Moles
of water are in the
reactant?
2 moles po.
Ayan. Okay, very good. Thank you. And then you have also other people, Loyola. Okay, Loyola.
How many atoms of sodium hydroxide are in each mole in the reactant? 2 po. Ay, 1 po pala.
1. Okay, how many atoms in each mole? Pero pag hiningi na natin, okay, next is nasol. How many moles of sodium hydroxide are in the reactant?
2 po.
Yan, okay, so you're going to consider this. And then the last one, wala na. You have other people, Barrientos. How many atoms of sodium are in the product?
How many atoms of sodium in the product? 2 po.
Okay, very good. At least now you're clear with that one. So again, thank you guys. Please take note. You have to analyze the questions because it's gonna be a little tricky. Now, any questions, Patrick?
Ma'am?
Yes. Yes.
Yung final answer po sa how many atoms of sodium in the product, isn't it 1 lang po sa product? Kasi coefficient po yung 2. Yung last question.
Hindi, yung sa kasi dito, it's not per mole ang tanong na natin. It's more on how many atoms na. So again, based on the explanation that was the process that was given earlier, remember yung 4th process or yung 4th step, kung ano yung coefficient niya, i-multiply mo sa bawat component na nasa loob. So again, it's not as specific as I used earlier na in each mole. It's almost similar with this one. How many moles of sodium are in the reactant? So ito naman, in the product. So ito total mo na siya. Okay? So yan po. So it's 2. Okay? So i-consider mo na siya. Hindi siya in each mole. As a whole na siya. Okay? Klaro po ba, Isaiah?
Yes po.
Okay. Thank you. Any questions so far with this activity? Wala?
Ma'am, may question po ako.
Yes, Patrick.
Doon lang po sa question kanina, how many atoms of sodium hydroxide are in each mole in the reactant? Bakit po naging 1 yung answer?
Each mole. When you say each mole, you're not gonna consider the coefficient. So, ibig sabihin, itong isang irasong lang to. Wala naman siyang
Yung sodium hydroxide
sorry.
po.
Sodium hydroxide are how many moles are in the reactant? It's 2. Pero dito, how many atoms of sodium in the product? It's 2 pa rin. Hindi siya 1. It's 2. Kasi nga, i-multiply mo yung coefficient dun sa sodium.
Yung reactant po ba yung
Doon sa
kaliwa
reactant,
or kanan?
sa reactant, wait lang. Kasi kung sodium hydroxide, wait lang, bumabalik siya. Pag sodium hydroxide, doon, dito, of course. And then sodium sa product siya. So dito, sodium in the product siya. So in-specify kung nasa ang lugar ka titingin. So dito tayo titingin sa product, hindi sa reactant.
Pero yung previous question po, reactant po ate yung...
Ito yung sa...
Ito? Saan po nakuha yung ano? Yung ano pa, fifth question. Yeah.
How many atoms of sodium hydroxide are in each mole in the reactant? So, how many atoms of sodium hydroxide? So, bilangin mo lang siya. So, ilan yung sodium? 1. Ilan yung oxygen? 1. Ilan yung hydrogen? 1. In each mole. So, hindi mo i-consider itong isang to. Kasi ang tanong niya is each eh. So, wala siya. Hindi siya consider. Ito lang, formula lang na to ang titingnan mo.
Ay, gets ko po, ma'am. Pero, kahit sinabi po na in the reactant, okay lang po tingnan dun sa right side.
Ay, sorry. Baliktad. Sorry, my bad. So, reactant, dito tayo sa product tayo. Kasi,
product po,
so, mali ako dito with terms of the reactant should be in the product. Thank you for clarifying that out.
Thank you, ma'am. Nalito lang po. Sorry po.
No problem. Thank you then. Okay? Okay, let me just make that correction. These are all on the same page on this one. Nagulo din ako. Thank you. So
Thank you, ma'am. Sorry po.
No problem. Okay. So yeah, let's move to the next one. Okay, this time we're going to be talking about reversible reactions. Now, usually, ang majority na alam lang natin or most common is the irreversible reaction or single direction reaction. But we also have what we call reversible reaction. Now, usually reversible reactions are common for reactants that are in the gaseous state or in the aqueous state. Okay? Because the materials then can occur on the same time or they can exist on the same state or the same environment. Okay, so here an example that we have here is sulfur oxide or sulfur dioxide plus oxygen will give you sulfur trioxide, and then sulfur trioxide would give you would also give or form or break down into sulfur dioxide and then oxygen. So this one above is what we call the forward reaction, and the one at the bottom is the reverse reaction, okay, or the backward reaction. Okay. Now, if we're going to combine these two, oh my gosh, wait lang guys, bakit nandiyan ka? Nakaano kasi ito eh. Yan. Yan. Okay, so here now, by combining both of that, since pareho lang naman yung mga reagents sa right side of the equation, sa left side, ang nagkaiba lang is that the direction of the flow, we combine it now as a reversible reaction, okay, using this symbol. So this is a double arrow, okay. Now, usually what would happen is that you have molecules of reacting in the space. So you have here an example, yung mismo sa air, okay. So you have sulfur dioxide and oxygen forming now your sulfur trioxide, and then it will be breaking down to sulfur dioxide and oxygen. Okay, so it tends to form. Okay, now, given that you're talking about a reaction that tends to move forward and backward, parang urong sulong, you have what we call, it will actually stop, or not exactly stop, but it reach a certain point wherein the reactions will be less na siya, or it will be kept on a minimum, and you call that as an equilibrium, a chemical equilibrium. So usually the reaction is very high, or the activity is very high at the beginning, and then at the long run, it will tend to have an equilibrium. Parang ano yan eh, pag nagbato kayo ng bola, or when you bounce a ball, 'di ba, yung unang energy na binagsak ninyo when you bounce the ball, continue siya. Then later on, what would happen is that it would tend to become lower and lower hanggang sa hindi na siya gumalaw. So that's almost similar if we're going to uh, describe it graphically. Or parang saan yan? Sa pag nagwo-workout kayo, guys. Sino dito ang mga nagwo-workout? Sino dito nag-gym pa? Sa akin nag-gym? Nag-exercise? Well, okay, so we have a few. Okay, now, siguro, I'm not sure if you've experienced this, na before pandemic, or before pandemic na lang, nag-exercise kayo na nag-exercise, then somehow, wala na kayo nakikita masyadong change sa katawan ninyo. Okay? So, that is what we call equilibrium. Kumbaga, na-maximize na yung mismong reaction or yung ikapapayat mo dun sa ginagawa mong activity. So, ano ngayon ang gagawin mo? Sa workout, guys, you call it that's plateauing. Okay? Nag-equilibrium ka na. Kumbaga, yun na ilalabas dun sa exercise mo. Now, para tumaas ulit yung amount na ikapapayat mo, ikakatrim down ng katawan mo, magdadagdag ka ngayon ng activities. It's either you extend or you increase the number of, yung number of frequencies ng activity mo. For example, yung leg raise mo, o kaya yung jumping jack mo, or yung jumping rope mo, instead na 5 minutes, i-extend mo ngayon siya para magkaroon ka ng more reaction sa katawan mo. Mas pumayat ka pa in the process. Okay? So, yan. Now, if we're going to express it graphically, so this is what it's gonna look like. So, here, you will notice the concentrations of the red and the yellow, the red and the green is actually referring to, okay. Saan ko lang yung mga okay. So, yung red and green are your reagents. So, you have SO2 for the green, oxygen for the red. And then the yellow line refers to your sulfate. So, what will happen here is that when it is undergoing a chemical reaction, when it hits on a particular space. So what will happen is that you will have a decrease in the concentration of the reactants. And by decreasing the concentration, it means that they are forming the sulfur trioxide. And if you will notice, habang bumababa, as both reactants are decreasing its value in the terms of concentration, it means kumukonti sila sa loob ng space na yon, the concentration of your sulfur trioxide is increasing. But once it has reached its equilibrium, okay, it's not going to increase anymore. It's going to stay there kahit na gaano pa katagal siya. Okay? Now, the only time that you're going to be causing it to have an effect unless you do something on the container. For example, taasan mo yung temperature, or i-agitate mo yung lagayan. Pero afterwards, kahit ni-agitate mo siya, di ba kunyari doon sa pag naglalaro kayo ng, alam mo yung snowball, parang ganon, yung snowball. Pag ginalaw niyo yung snowball, yung mismong particles ng snowball sa loob nun, nagkakagulo, di ba? Then afterwards, magpapahinga na sila or magpaplato na sila. So, ganun yung nangyayari dito. Now, on the other hand, this time, this is for the backward reaction naman. So, what you will notice here is that for the reactant na kung saan you have there your SO3, the concentration of SO3 is also decreasing. As it decreasing, the components of the products are increasing. But once it also reaches the equilibrium point, hindi na po siya magdadagdag, hindi na rin siya magbabawas pa. So hanggang doon na lang yung concentration level niya. Okay? So kahit na gaano katagal siya, it will remain constant once it reaches equilibrium. Okay? Para sa aircon niya sa kwarto, for example, ang kwarto ninyo is maliit or malaki. Pag binuksan niyo yung aircon, di ba may part na mainit, may part na malamig, then later on, magkakaroon na tayo ng what we call equilibrium. Pantay-pantay na yung equilibrium or yung mismong temperature dun sa kwarto nyo. Okay? So, yan. Now, usually, chemists tend to express equilibrium as a numerical value. So usually this is relation to the concentration of the reactants and the products in the equation. So here, if you will notice, you have there the letters in capital and letters in small caps. Okay? Or big letters and small letters na lang. Okay. For the ones in the big letters, it represents the actual compound, and the small letters or the coefficients will represent the number of moles that are available. Okay. So if we're going to get the constant of an equation, since as I mentioned, you're going to be quantifying it, we use the symbol KEQ, okay, or the equilibrium constant. Now, the equilibrium constant is the ratio of the product concentration to the reactant concentration at equilibrium. Now, usually, it's the concentration of the power of the moles of that substance in the balance equation. Kailangan balance siya, otherwise it's not gonna get an equilibrium, okay? Now, if you're going to equate it, okay, so KEQ is equal to the product over the reactant. So the product raised to the coefficients. So kung C raised to the C, D raised to the D, and then A to the A, B to the B. Okay, so yan ito lagi natin malimit na makikita in terms of as we go through the pH, pH, and the buffer system. Okay, so ito ang importante natin. Kailangan alam natin kung paano isulat ito. Okay, so let's have an example here. Okay, so let's have an example. So try writing the equilibrium constants of the following. So sulat niyo sa papel, and then we're gonna share screen. I'm gonna allow you to share screen. Okay. So write the equilibrium constant. I think naroon yata doon sa pinadala ko sa PDF ba? Or wala?
Yung ano lang po, equation
Okay.
lang po.
Yes. Write down the equilibrium constant of the samples that I gave here. So yung una, anyone who'd like to try letter A? Iba naman, Asaya. Iba naman, Relator, Mariel.
Ayan po, sana nakikita niyo po yung sulat, pero ano siya, O3, tapos yung exponent niya po, 2 over O2, tapos yung exponent po is 3. Sana nakikita siya, ayan po.
Okay, sino yung nasa taas? Si 2 o yung si 3? 3O2?
O3 po, yung sa taas.
Okay, so raised to the 2, and then sa baba is 203. Okay, so ito yung itsura niya. Okay? Thank you, Marielle. How about another one? Other people, please. Wala na naman yung iba. How about Karonan?
Makikita po ba?
Tingin.
Ito lang po, wait lang po. Itong part.
Sige lang, go.
Ito po yung nakabox.
Ayan. Okay. Sige. Okay, thank you. Wait lang guys, ha. Yan. Grounded ang ano ko. Hello? Okay. Can you hear me, guys? Wait lang, kasi nag-ground siya. Hello? Ito. Thank you. Okay. So the other one is, okay, so nasa taas, CnH3 raised to the coefficient of 2. And then, the concentration of nitrogen, since wala siyang coefficient, wala siyang superscript. And then, hydrogen gas raised to the power of 3. Okay. Let's have another one. Iba naman. Ikaw na naman. Let's have Rimando. Romel. Sige lang, go ahead. Take your time. Mahaba oras natin. Mahaba-haba yung ano natin. Medyo mahaba-haba kasi yan eh. Konti na lang tinira mo sa akin. Wow. So, yeah. Oh. Any update, Mr. Remando? Wala tayong isa-solve dyan na. I-rewrite nyo lang siya to form the KEQ or the reaction quotient. Ano ba si Timmy? Okay. Hindi pa siya iho. Ayan, sige. raised to the 4. Okay. So, kailangan yung coefficient raised to the power of the products or the reactants and products. Okay? Thank you, Mr. Remando. So, ito dapat ang itsura niya. Okay? Ayan. Any questions so far with with writing expressions, compound, clear. Okay? So, that's good. Let's now proceed to the next slide. Okay? Haba-haba. Mababa tong lecture na to. Okay. At kasi ang pin-upload ko pala is PDF. Siya nga. Wait lang guys. Okay, so please advise once you see it up on your end. Thank you. Okay, so this time we're going to be talking about acids and bases. So as mentioned ni Prof. Dave kanina, remember the different properties of acids and bases? And we're going to be talking about pH, okay, or power of hydrogen. So when you talk about acids, these are substances that produces hydrogen ions in water solution. So an example is hydrochloric acid would give you hydrogen ion and chlorine ion. On the other hand, bases are usually substances that produces hydroxide ions in water solution. So we have sodium hydroxide that will give you sodium ion and hydroxide ion. Okay? Now, ano ba yung mga characteristics ng acid? Okay? Ano po ba yun? Anyone? Characteristics ng acids and bases. Pag sinabing acid, ano ba yung naalala mo? Yes. Okay. And then if you recall, yes, Pastanes, other things that you'd like to share aside from the one that were mentioned by Professor Dave kanina. Romel, go ahead. Okay, that's good. Other characteristic aside from the pH. Mary Grace. Marian pala, Marian Grace Caronan. Oh, okay, that's correct. Okay, that's correct. So usually it has an effect in terms of taste. Acids are yung term, maasim, right? Most of the acids are maasim, while bases are bitter. Okay, you have also other people, Karil, and okay, that's correct. Those are usually some of the characteristics of acids and bases. Very good, thank you. Okay, so let's go now to the next one. Wait lang. Wait lang guys ha. Yan. Okay, Now, in terms of acids and bases, it's actually differentiated on the type of acids and bases that we have. We actually have three classifications of acids and bases. We have Arrhenius definition, wherein acid, the ones that increases the hydronium ion solution. By the way, this is hydronium ion. Okay, yan. Now, most of the time, instead of writing hydronium ion, nilalagay na lang natin hydrogen ion. Okay, so hydrogen ion, and then base increases hydroxide concentration. Then we have also Bronsted-Lowry definition. So reactants that donates protons are acid. The one that accepts protons are bases. And then we have the Lewis definition, wherein acids are the one that accepts electron pairs, and base is the one that donate electron pairs. Okay, so yan yung definition nila. Now, most of the, in terms of studying pH and POH, ang laging ginagawang basis yan is the Bronsted-Lowry acids and bases, okay? Because the idea here is that acids donate proton and bases accepts a proton. Okay, wait lang guys ha. Okay, so here is an example of a reaction of an acid reacting in water. So what would happen here is that the hydrogen from the hydrogen chloride would dissociate and would form a bond with water, forming now what we call the hydronium ion. Okay, and then you'll be having a liberation of the chlorine ions in the reaction. Now, if in case it's going to be a base, you're going to be having here ammonia, which is the universal example for bases, and then you have water. So what would happen here is the excess water, or the one of the hydrogen in water, will be removed and it will bond with ammonia, forming the ammonium ion and the hydroxide ion. Okay, so usually this is the setup for basic reactions. Okay, now what would happen is that once you have already dissociated to form those kind of compounds, you have what we call a base pair. You have now a conjugate acid-base pair. So for example, you have an acid and then the other one is going to be acting as a base. Ang kanyang base pair would be the acid, or the one with the negative ion on the product, na wala yung um, reversible reaction dito, yung yield symbol or yung arrow symbol. And then the base, the conjugate acid base pair 2, or the base on the reactant, will be the acid on the product. Okay, so kung dito acid siya, sa product nagiging base ang action niya. So yung base sa reactant will become acid in the process. Kaya nagkakaroon tayo ng what we call the conjugate acid-base pairs. Okay? Now, more on examples of an acid-base pair. So example here is hydrogen fluoride donating hydrogen ions. It will now become fluorine ions. And then here, yung water, nag-accepts naman siya ng hydrogen that's coming from hydrogen fluoride, giving you the hydronium ion. Okay? Okay. Now, in the reaction that we mentioned earlier, what you're going to be seeing here is the pairing. So, pinakita lang dito yung mismo pagpe-pairing niya. Okay? So, yung acid siya will be now becoming the conjugate pair in the product. And then, yung base kanina would become the conjugate acid in the product. Okay? And then here's an example naman, yung pinapakita naman, yung explain further naman, yung pagdating sa base. So you have here ammonia, which is considered as an acid here. Okay? It will now become as a base here. Okay? And then, yung water dito will become an acid and then will become the base here. Okay? Base acid. Okay? Next one is how do we solve for the ionization constant of water? Kanina, equilibrium constant ang pinag-uusapan natin. Now, this time we're gonna be talking about ionization constant of water. Now, usually what we have is two atoms of water, okay, pure water. Now, one of them will be acting as an acid and one will be acting as a base, okay? And then it will form now or it will yield now your hydronium ion and your hydroxide ion. Now, normally, if you're going to look at books and online references, hindi na po nila sinasama to. Dinadrop na rin nila si hydronium ion. Kasi what would have is that since yung isa is just water lang, and then yung hydronium ion is what we call kumbaga, meron siyang nakadikit na extra hydrogen lang. So, tinanggal na yung dalawa sa equation. It's further simplified to form this kind of equation. So, water yielding hydrogen ion concentration and hydroxide ion concentration. Now, this is an equation known as the auto-ionization of water. Okay? Now, based on that one, we're going to get the constant of water. So, di ba kanina, dapat to is Kw, sorry, my bad. It should be Kw, constant ng water. So, it's gonna be Kw is equal to the concentration of hydrogen ion times the concentration of hydroxide ion all over the concentration of water. Now, please take note that water does not have a particularly pure water does not have any concentration. So, nasisimplify na lang siya into this equation, okay? So, nagiging ganito na lang siya, okay? Or ganito na lang itsura niya. Okay, so it's gonna be Kw is equal to concentration of hydrogen ion and hydroxide. Okay, mamodify ko to later. Dapat talaga isa na lang. Pero sinusulat ko pa rin para reference pa rin. Kasi nga, sabi ko nga sa inyo, iba-iba yung mga nakasulat sa mga libro. Okay? So, it's gonna show us either like this or like this. So, it's isa lang naman yan. Now, the Kw of water is usually at 1 times 10 to the negative 14. Yan yung constant niya. Okay, that's the constant value. Now, given that you have this constant value now, you can actually get the concentration of hydrogen and hydroxide. So, using quadratic equation, okay, so since equal lang sila, so x times x squared is equal to 1 times 10 to the negative 14, then square root both sides, you're going to get the value of 1 times 10 to the negative 7. Now, if in case you haven't, or you would like to do that on your calculator, do you have your cell phone? You can actually have your cell phones with you guys. Either you have your cell phone or you can use your actual calculators. So usually, for you to get that, ang square root kasi is subtraction or i-divide mo yung power nung base 10 mo. Okay? So let me just pair this up para makita nyo. Ma-share ko sa inyo to. Wait lang, try ko lang i-share sa inyo. Ayan. Okay. So this is a Can you see my screen now? So what you're looking at right now is yung hypercalc na application sa phone ko. So this is almost similar to an actual sa calculator. Medyo pangit na yung version na to, pero yung dati kasi yung ginagamit yung binary na design, yung ginagamit mismo natin ngayon sa actual calculator. So for this one, usually what I do is get the menu, then mode lang natin is classic para dapat is expression, kaya lang kasi hindi nakikita yung history dyan. Pero here, you can actually use this as an actual sort of based on the using the expression. Okay, so let's have an example that we have. So as mentioned earlier, you have there 1 times 10 to the negative 14, right? So pag sinulat natin, wait lang guys ha. Let me try to share an actual screen pareho para pareho nyo nakikita yung yes, question. Yeah. Somebody raise their hand. Okay. So here, so pag pinress nyo lang, just press 1, then exponent, then yung mismong number, yung value, yung power niya, 14, then add negative. Okay? Let's see if I can add the square root. Yan. Okay? So yun yung makuha ninyo. So that is the value of your hydrogen ion. So that's how you do it on your calculator. Now, please take note that for solutions, the hydrogen ion concentration, the concentration is higher than the hydroxide value. Okay? For basic solution, the hydroxide is the one that is higher compared to the hydrogen concentration. So yeah. Now, so let's have an example calculation here. So you have here given the concentration of hydrogen, but you're asked to compute for the concentration of hydroxide given. Hydroxide is given, but you're asked to produce the concentration of hydrogen. So what you're going to do using your calculator, so clear lang natin. So i-write nyo lang. Remember, the idea is that the concentration of, or the concentration of water is equal to the concentration of hydrogen times the concentration of hydroxide. So given that Kw is equal to 1 times 10 to the negative 14, and we have the value for the, wait lang. The value of hydroxide is 0.0025. So i-divide nyo lang yung Kw with OH. So using your calculator, you have 1 negative 14 divided by 0.0025. Yan. So the answer now is 4. So that is the concentration of your hydrogen ion. Okay? So given that this is mataas yung concentration ng hydroxide natin, the solution therefore is considered as basic. So pero that is how you do your calculation on your calculator, or yan yung pagpe-press ng or sequencing sa calculator. Okay? Meron bang nahirapan i-execute ito sa inyong side? O lahat nakuha naman? How about the others? I mean, in terms of sequencing sa calculator. Kung yung ganito yung gagamitin ninyo, o yung ganito yung mode ng calculator ninyo, madali lang siya. I-type in nyo lang yung operation, sunod-sunod siya. But if you are using if your actual calculator naman is yung classic, okay, so you really have to, uunahin nyo muna yung mga multiple operations before you alam mo yun, inner operations muna bago yung nasa labas. Pero let's see if we can do the execute or have the same result divided by, pero alam ko kaya rin to. Yan. So, ganun din ang resulta. Okay? Pero pag mamaya, pag nagpunta na tayo sa BH, dun magkakaroon ng change konti yan. Okay? So, yan. So, let's continue. So, this time, it's the same process, but this time we're going to be computing for the hydroxide given the concentration of an acid. Okay? So, here, okay, so, ganun din ang gagawin natin. So, yung Kw divided this time by the concentration of the acid. So, 1 exponent negative 14 divided by 1.3. Yan. So, kaya may bar siya kasi it's a repeating value. So, round out na lang natin sa 7.7 times 10 to the negative 15. And this is a very acidic value. Okay? Kasi lumampas siya dun sa 14. Okay? So, yeah. Okay, question so far? Okay. Thank you. Okay, now this time we're going to be using the pH. So usually this is a measure of acidity wherein the algorithm, you're using algorithm of base 10. Remember kanina 10 to the negative 15, 10 to the negative 7. Para mas simplified yung expression natin, we're going to use logarithm. Okay, so the formula for the pH is a negative log of the hydrogen concentration. Okay, so again, using the same either which. Hydronium ion concentration, hydrogen ion concentration. Pareho lang din yan. Okay? And then, kung meron ka naman pH, you're going to get the anti-log of the pH. Negative pH, anti-log. Okay? To get the hydrogen concentration. Now, POH is also the same thing. Negative log of the hydroxide concentration. And to get the reverse value, or baliktad naman natin kukunin, that's gonna be negative POH tas log 10. Okay? And then pKW, which is the power of the KW, so negative log of 1 times 10 to the negative 14 will give you the value of 14. Okay? So, here, so given ito, example natin kanina. So, kung ito yung given natin, let's get sa calculator, guys, ito yung gagamitin nyo. Inverse log ninyo. So, ang gagawin nyo dito, so ito yung value natin. Wait lang, ilalog natin to. Yan. So, 14 siya. Then, if in case you're going to go for the hydrogen power concentration, or hydrogen concentration, tanggalin yung negative. Ito yung bibigay nyo sa akin sagot pag pH eh. Okay? So, dagdagan nyo lang ng negative, then shift, then log. So, yan. Para babalik siya dun sa dati. Okay? So, ulitin natin. So, balik natin siya dun sa dati. Tanggalin lang natin. So let's say ang value natin is 14. Kukunin natin yung pH value natin. Let's say, let's have 2.3 na lang. 2.3 yung pH niya. What is the hydrogen concentration? So, lagyan nyo lang ng negative and shift, then log. Okay, so that's 5.0, okay, times 10 to the negative 3. So, yan yung kanyang concentration. Now, you can actually show this. Ano ba yun? Paano ba yun? Ayan. Okay, so yan yung magiging sagot niya. So para makita ninyo yung mismong ano niya, it's 5.01 times 10 to the negative 3. Okay? So yan. Any questions so far before we move on? Nakakasunod naman po dun sa calculations. Guys, wag maiya. Yes, Justin, Miss Nasol. Actually, itong ginagamit natin, sige, I think, ito, layout ko using ito yung sa scientific calculator mo, yung mas malaki ang screen, tama? Oo nga, yeah, it's the same. Ito yung mismong yung screen mo, pag nakita mo, dalawa yung nasa taas. So, meron siyang sa taas na nakalagay, meron sa baba. Yan yung mismong common ngayon. Ito po, yung luma, ito yung naabutan ko. Ito yung classical. Okay, yung isang linya lang. Pero majority ngayon ng mga Casio, ang expression type yung ginagawa nila. Okay, so ganyan. So kung ganito po yung gagawin ninyo, you just write it as a normal formula. Okay? So isusulat mo, for example, yung sinample ko kanina. So kung kunin natin yung hydrogen ion concentration. Okay, let's say 2.3. So sulat lang natin 2.3. Lagyan mo ng negative. Tapos, wait lang. Mali. Start all over. Wait. So, negative log of 2.3. Negative. Yan. Nag-error siya talaga, di ba? Ginagawa ko dyan is, log mo lang siya, then 2.3, then negative mo. Ba't nag-error ka pa rin? Oo nga, nag-error siya. Yes, Mr. Barrientos. Oo nga pala. Sorry, my bad. Baligtad nga pala. Oo nga, sorry, my bad. Ano ba yan? Pati ako nagulo na. Shift log, negative 2.3. Ayun. Thank you. Ba yan? Pati ako nahiya na ako. Anyways, so nakuha kanina. Pero kung pH siya, let's say, kung let's say ito, kunin natin yung value nito sa calculator. So, sulat nyo lang siya. Kahit na, wag nyo munang ilagay yung negative. Ito lang, kasi pwedeng gawin natin to afterwards. So, sulat nyo lang log. Tapos, 1 exponent. Huwag nyo nalagay yung times 10, guys. So, you don't need to write the 10 kasi automatic maglalagay ng times 10 when you press the exponent button. Then, lagay nyo kagad yung exponent value and then the sum symbol here o yung sign. Okay? So, automatic na lalabas siya dyan. Now, since may negative ka dito, lagay mo na lang yung value niya afterwards. Okay? Yan po yung mangyayari dyan. Kasi dito, I'm not sure kung makuha mo. Nag-error siya kasi nga hindi pwede may negative. So, ang gagawin nyo na lang is, yan, dito natin tuloy. Yan. So, i-press mo na lang yung negative para makuha mo yung value. Ba yan? So, yan. Okay? So, yan. So, ulitin natin ha. So, log lang, then 1 exponent 14. Kahit na mauna pa yung negative ninyo at saka or 14, pareho lang lalabas. Then, sa kanya i-press yung negative para makuha nyo yung value ng pKW. Okay? Questions? This is the expression or yung para kung maga sa pH, hydrogen, this is the power or equilibrium constant ng water, pure water. Okay. Kung sa pH, sa hydrogen ion, pKW is the concentration for water. So let me go back to this one. Okay, so here is how we usually also can solve for the pH and POH. So di ba remember na sinabi natin kanina, yung pH is coming from the value of hydrogen ion concentration. POH is derived from that. Okay, so we can actually compute for that one given that the pKW is equal to 14. So 14, yan. So dito nang galing yan. And then x plus x will give you 2x. So divide mo lang sa 2, you will be having now, wala siya. Okay, so that would have now the value of hydrogen and hydroxide would give you 7. Okay? And that is the neutral value. So pag pH niya is 7.67 pababa or 7 to 1, that is acidic. From 7.1 pataas or 7.1 pataas, that is basic na. Okay? So yan. So yung dugo natin is actually more of on the basic side, 7.4. Now, sorry. Ito pala yung for, wait guys wait lang. Nangyari dito. Sorry. So, kanina, di ba, yung sa pinakita natin, ito yung basic natin. Yan. So, pag kinumpute na natin yan, so you'll be having now pH, yan, negative log of H, given that midway of that one, it's 10 to the negative 7. So, pH is 7. And then for POH, yan. So, it's negative log of hydroxide. And then, neutral pa rin is 7. Okay? Now, here in this expression or in this equation, you're given the concentration of the acid, which is 3.2 times 10 to the negative 4. Now, although you can see the value already or the answers here, pero we'll still proceed with how to do the calculation on your calculator or how are the keystrokes in the calculator. So, ganun din. So, since we're looking for the pH, okay, so, madali lang. So, negative log of the given value. So, negative log of 3.2 times 10 to the negative 4. So, type nyo lang siya. So, log 3.2 exponent negative 4. Okay? So, since negative siya, pindutin nyo lang yung negative sign. Wait lang guys. Nag-error siya. Nagbabago siya dito. So, yan. So, i-rewrite nyo lang. Kasi pag naging positive siya, since meron tayong minute details, nagbabago yung value niya. So, huwag nyo na dito siyang ipindutin. So, isulat nyo na lang siya diretso. Okay? So, if the hydrogen concentration is 3.2 times 10 to the negative 4, the pH is 3.49. Okay? And then on the second one, if hydrogen concentration is 1 times 10 to the negative 3, okay, what would be the pH? Okay, 1 exponent negative 3. Okay, so yan yung sagot niyo. Now, since wala siyang value na mas mababa pa, pwede natin gamitin yung minus sign dyan. Pero pag meron siya like 3.2, 3.3, or anything that is not exact whole number, or nasa one system, hindi natin pwedeng tanggalin. I-manual nyo na lang na isulat dito. Okay? So, yan. Now, if you will notice, guys, as yung value nito is lumiliit, di ba? Times to the negative 4 is mas maliit kaysa sa times to the negative 3. So, what happened is that the value is inversely proportional. So, as your value tends to increase, the pH is going lower. And the lower the pH, the more acidic it becomes. Okay? Yan. Now, another example, ito naman. So, nitric acid. Now, this is, again, a very strong acid. So, let's do the calculation here. So, kinukuha naman natin is hydrogen, di ba? So, katulad yun, as mentioned kanina, negative log ulit. So, log 0.76. Yan. So, the answer now is 0.12. So, very strong acid ang nitric acid. Okay? Kahit na wala pa siya dun sa concentrated na value niya, which is 14, if I'm not mistaken. Kasi ang sulfuric acid is 16. Okay? Definitely, konti lang yung laman niya or konting concentration lang ng nitric, mataas ang pH niya. Because these are part of the strong acids. Okay? Yan. So here, as mentioned earlier, ito yung pH neutral, which is 7. Now, kaya nga guys, di ba, if you remember, yung mga ginagamit-gamit natin, di ba? Ano ang mga samples na meron sa bahay na kakabit lagi ng salitang pH, di ba? Sabihin nyo, pH care. Yan, sa mga babae. Okay. Ano pa? You have also suka. Suka is acidic, di ba? Sabon is basic. Yan. Kaya nga, di ba, girls and some boys, rather, some guys are, lalo yung sa balat, okay? Or sa mukha, sa kutis ng mukha natin. Okay? Meron tayong mga ginagamit na facial wash. Okay? Do not use facial soap. Bakit po? Ngayon kasi with the technology, marami tayong ginagamit para sa mukha natin, yung mga, ano mga ninagamit natin dyan, yung mga pampatanggal ng mga exfoliating, chuchu dyan, di ba? So usually those are the ones that are being applied on our face. So usually those are kind of acidic. Kasi po, yung face natin, it's medyo acidic po siya. Okay? Medyo sensitive yan. Pag nagkaroon ka ng, pag tumaas ang pH niyan, naging basic yan, kagagamit ng sabong panligo. Okay? The skin becomes drier, and then prone ka ngayon sa mga breakouts, mga tigyawat, okay? Tapos kung hindi ka rin natutulog, tapos hindi ka nag-aalaga ng balat mo, it will always lead to a lot of breakouts, okay? Now, sa babae, meron tayong tinatawag na pH care. Now, bakit po, with this technology that we have right now, hindi advisable gumamit ng sabong panligo, lalo sa sa mga babae. Anyone who has an idea? Bakit kailangan gumamit ng pH care or lactacid sa mga babae? Pwede gumamit ng ano? Yes? Kanyas. Very good, Miss Kanyas. Very well said. Totoo yan, guys. Ang female reproductive system is very acidic. So, kung gagamitan niyo siya ng sabong panligo dun sa part na yon, nako, you're going to neutralize the acidity. Okay? And when you neutralize the acidity there, meron kasing guys, okay maano ha, pasensya na kung dinidiscuss ko to. Meron kasi doon, bagay, magiging mga nurse naman kayo or future nurses. Sa babae kasi, meron tayong tinatawag na normal flora and fauna, yung mga nakatirang microorganisms sa katawan natin. And those who live on the vaginal areas are usually the ones that are acidic. Okay? Pag naging basic yan, tutubo na ngayon yung mga tinatawag nating mga fungal infection, yung mga hadhad. Ano ba yan? Hadhad pa doon tumutubo. But anyway, so yun yung nangyayari doon, guys. Okay? Kaya nga, pag nagkaroon ng problema, tapos, kunyari, nasa probinsya kayo, malayo yung pinakamalapit na SM na bibilhan ninyo or soaking Watsons or grocery ng pH care na ubusan kayo. And you need to do something about it kasi nagkakaroon na siya ng fungal growth, nagkakaroon ng konting itchiness. Okay? Pag nagkaroon na ng itchiness, guys, you can always refer sa turo ng mga matatanda, which is gumamit ng anong meron ka sa kusina mo na pwede mong gamitin if in case wala kang pH care. Anyone? Yes, Miss Mantilla. Hindi, but baking soda. Baking soda is a base. Medyo base yan. Para sa ano yan. It's all about the base. Yes, very good. Suka. Kumuha ka ng konting suka. Hindi naman kailangan mag-adobo dun sa babae. Konting suka lang. Ihalo nyo sa tubig, tas yun ang panglinis nyo dyan. Mamamatay lahat ng mga hindi dapat na nakatira dyan. Okay? So, lahat sila. Yes, Mrs. Sol, you have questions? Okay, thank you. No problems. Kaya nga 'di ba, yung sa mga salita nila, may asim pa si Lola because of that saying. Kasi nga acidic pa doon. Usually as you age, medyo nagbabago rin yung flora and fauna doon. Kaya kailangan let's keep it healthy girls ha. So gagamit kayo ng mga materials that is friendly to your skin. Kahit sa balat natin, sa face natin hindi pwede rin yung laging bath soap ang gagamitin natin. Kaya nga may mga facial wash tayong ginagamit. Okay? Kaya nga meron tayong facial foam, facial wash, yan. Tapos, di ba yung ginagamit na astringent is also acidic. It's a mixture of boric acid and hyaluronic acid na medyo mataas ang pH level yan compared to normal bath soap. Okay? So, any question in terms of pH ranges? Wala. Baka natatawa ka, Isaiah? Ayaw niya ng adobo. Sige, magpapangat tayo doon. Ginagamitan rin ng sunga ang pangat. Pero yun, totoo yun, guys. Nung mga lola, pag narinig, hala, nung ginakamot mo dyan, nangangati ka dyan, magsuka ka, maglanggas ka. Ayan, sabihin na ng mga matatanda. Okay, so let's move on. Saan ang controls ko? Where are my controls? Okay, so yan. So here's another example. So rain, it has a pH of 4.82. Okay. So given that the pH range, what is the hydrogen ion concentration? So ganun ulit. So yung pH, so inverse log, shift log, 4.82. Yan. Bakit na ano? Yan. Hindi maliit yung kanyang screen eh. Ayan. So, this is the decimal value. Hindi nakikita kasi masyado niyang pinapakita lahat ng mga values doon. Pero it's supposed to be 1.51 times 10 to the negative 5. Okay? By the way, guys, in terms of expression, usually I go for 2 decimal places. Tapos, round off niya with the nearest value. Okay? I don't think we need to go to the rounding off. Alam niyo naman if it's even, tapos basta anything that's greater than 5, regardless kung even or odd, it's add 1. If it's less than 5, as is, di ba? Wait lang guys, ha? Anjali, si Ome nandun sa silya nakadikit sa akin, natutulog. Ano? Kanina. Anyways. Yan. So here naman, if it's 3.3, what will be the hydrogen concentration of orange? Okay? So ganun ulit. So inverse log, negative 3.33. Yan. So it's 4.67 times 10 to the negative 4. Now, what if you're asked to get the hydroxide? Now, if you're asked to get the hydroxide, pinapakomplicate ni Ma'am Santiago yung buhay ninyo eh. Okay? So, ang gawin nyo lang, diba? Remember, 14 total ng pH at saka POH. So, kung 3.3 na si, wait lang, nagpumabak yung presentation ko. Yan. So, kung pH niya is 3.3, what is POH? So, i-subtract nyo lang. So, 14 minus 3.3, that is POH. So, get the the hydroxide concentrations, shift, log. Okay, then negative. Yan. So, it's 2.1 times 10 to the negative 11. That is your hydroxide concentration. Okay? Then 10.67 is your POH. Okay? Any questions so far? Yes, Lauso. Yung 3.33, nakikita nyo ba kahit maliit yung yung calculator ko or gusto nyo malaki siya? Okay. So, yung given natin is 3.3 yung sa PowerPoint, di ba? The pH is 3.3. So, pH yan. So, para mag-get nyo yung POH, remember, yung POH is ang sum ng pH at saka POH is 14. So, isubtract nyo lang yung 3.33 sa 14. So, 14 minus 3.33, which is the pH, yung value niya will become the POH. Okay? So once you get the POH, to get the hydroxide value, it's gonna be shift log 10.67 negative. Okay? So since nakikita nyo siya ng ganito, yan. Ito po yung value niya. 2.1 times 10 to the negative 11. Okay? Or pwedeng 2.14 since 2 decimal places. Nakuha yung sequencing, Ms. Lauzo? Thank you. Others, how about the others? Lahat ba nakakasunod dun sa calculations? Sa key sequencing? Okay, that's good. Thank you. Okay. Now here, yan. Ito naman yung OH naman ang given niya. Okay. So if you will notice here, the given is you have OH 2.9. Ang hinihingi niya naman is pH. So, dalawa yung pwede niyong gawin na pag-solve dyan. It's either you get first, okay? So, dito, ang ginawa niya is inuna mo niya kinuha yung POH kasi whole number siya. Okay? Then, subtract sa 14, ang value ngayon ng pH na is 10.46. Or, you use this one. Now, parang ako guys, I would suggest ito ang gamitin ninyo. Kasi po, yung value ninyo, mas madali kang mag-round off at this point. Diba? Let's say, kumbaga, hindi ganun kalaki yung impact. Kasi pag nagkamali kayo sa pag-key in dito, lahat apektado na. Okay? Pero either which, you can actually use the other process as a check and balance. Okay? So, paano yung calculation dito o yung keystrokes dito? So, ang gagawin mo lang is, so the given is a 2.9. So, log siya, di ba? So, log ng 2.9 exponent. Ayan. So, para makita natin, ayan. Ayun pala, 3.54. Yan. Decimal value. Okay? So, yun yung kanyang POH. POH pa lang yan. Ang kailangan natin is the pH. So, since negative ang value mo dito, i-add mo na lang siya sa 14. Oops. Wait lang guys ha. Yan. Yan. Wait. Di siya talaga. Wait. Imaano nyo na nga lang. Ayaw niya akong pinapahirapan niya ako eh. Yan. So, 10.46. Okay? Now, if you want to use the other way, ganun po. So, di ba, yung 1 times 10 to the negative 14, i-divide nyo lang by 2.9 times 10 to the negative 4. So, 1 exponent negative 14 divided by 2.9 exponent negative 4. Okay, so the answer now is ito. 3.45 times 10 to the negative 11. And then, yan. Dati kasi na ano mo siya, yung automatic na equal niya o yung answer niya, whatever you answer, pwede mo siyang i-pull up eh. Ngayon hindi mo siya basta-basta na ma-pull up na eh. Or I need to study this newer version. Binago kasi nila yung version eh. Nawala. Yan. So yan. So the answer now, wait lang, nagbago yung slide. Yan. Okay? So it's the same answer then. Okay? So you can actually use the other as a check and balance. Okay, so I have more examples here that you can study on. Yan. Okay? So yan. Any questions so far, guys? None. Okay, I'm going to end the session now for the discussion on this one. Kasi po, meron po tayo pang isa pang activity, which is the laboratory. Let me just share our TBL Hub. Wala si TBL Hub. Then on Thursday and on Friday, I will be uploading yung sa buffer. I'll continue with the discussion on the buffer and then also have more exercises and assignments on that one. And then you'll have your exam on Friday. Okay, so here, matagal? Wait ah. Alam ko na ba't matagal. Kasi ini-present ko yung buong screen. Dapat tab lang para mas mabilis. Yes, Miss Barili. Depende sa given mo, Iha. You have to specify. Ang given mo ba is pH? Basta kung pagitan lang ng pH and POH, yes, minus 14. Pero kung given is hydrogen concentration and hydroxide concentration, gagawin mo siya munang POH or pH, whichever is applicable, then saka mo siya isusubtract sa 14. Okay? Wala, tagal na. Wala, ayaw, tagal na niya, no? Wait lang guys ha, medyo matagal lang. Nangyari, walang tagal. Naman pala. Wait lang guys ha, lipat lang ako ng net connection. Yan. Baka later, is either later on, mag-upload ako or by Thursday, yung mga activities, parang practice calculations ninyo. Pero it's still gonna be graded. So, all your efforts will not be, you're not gonna be wasting your efforts there. Hala, ang tagal. Bakit? So. Yan. Okay. Here, on your TBL Hub, you will notice there that I added a new laboratory activity, which is properties of acids and bases. Now, I have here 3 components. So, yung una po is a page wherein you're going to find your procedure for the activity. So, this is more on simulations, guys. Kasi nga, sabi ko nga sa inyo, dapat gagamit tayo ng red cabbage or red repolyo. Kaya lang wala akong makitang red repolyo. At ang mahal-mahal ng repolyo ngayon. 80 isang piraso, napakaliit pa. Okay? So, yan. Now, here, originally, this is coming from Amrita. Nagpaalam na ako sa Amrita. And actually using this for my study as well. What I did is, I already isolated the steps. Okay? So, yan yung steps na yan. And then, I have here the animation. Now, this is actually your guide on how to do the simulation, okay? So, you can watch this on your free time if you'd like, okay? And then, you have the actual laboratory. So, if you're doing in a laboratory, this is what you're gonna be experiencing. Para at least ma-feel ninyo, kahit virtual lang, na nagla-laboratory tayo ngayon. Okay? So, yan. Now, on the next one, okay, is the simulation. So, click nyo lang siya. You'll be having now, yan. So, originally guys, ito ang makikita ninyo pag kinlik nyo yung susunod na component nun. Okay, so i-click nyo lang siya. Then, you'll be having now the simulator. So, in the simulator here, you have drop-downs. Okay? Then, i-identify ninyo kung acid or base lang siya. Okay? So, what you're going to do is you're going to carry the dropper, place it on the red litmus, click nyo lang para ma-release. Now, although alam nyo na kagad, ay, naging blue si red, so alam nyo na kagad. Pero hindi nyo siya pwede siyang i-click or identify kung acid or base siya until you have completed the activity. So, yan. So, open na ngayon siya. Acid ba siya or base? So, given sample 1, sige, giveaway ko na yung sample 1. So, click na si base, yan. Okay? So, yan. Then, usually may lalabas na inference. Okay? Now, on your going back to our TBL Hub here, ando dun sa third page, or third item do sa activity, yung sasagutan ninyo. Okay? Wait lang ha. Matagal mag-load siya. Hala, tumagal na. Hala, tigil, time out. Ito. So here is an assignment component. So here you will find the actual report sheet that you're going to answer. Now, I would suggest guys, i-download nyo muna yung document bago nyo sagutan. Kasi baka yung iba sa inyo nagsasagot ng, tawag nito? Meron ba sa inyo dito na inlay siya nagsasagot? Kumaga habang nakasulat doon sinasagutan? Kasi minsan may mga, I'm going to try again ha, kasi may mga iba sa inyo dyan na ang nangyayari is, hindi ko nakikita yung sagot nila. Kailangan kong download muna yung document bago ko makita yung sagot. Okay? So, sana po i-download nyo muna yung document or if you're using other applications, mura lang, libre naman yung Adobe Acrobat. You can download it for free. Okay. Tagal. Yan. So, you have here the document. So, pag kinlik nyo siya, you'll be opening a PDF file that would ask you to download it. Wait, ha? Let me share this one instead. Okay, so yan. So you have here Adobe Acrobat ng PDF ng document. So you can just use your fill and sign. Yan. So like yun lang yung pangalan nyo dyan. So yan. So you have here the samples. Okay. Anyari? Hala. Yan. Okay. So yan. So here is the part you're going to fill up. So dun sa natin, para magkasya, yan. So di ba dito, so if you're using your computer, you can actually use it like this para pareho nyo nakikita. Ayaw mo Ayaw niya guys. Ewan ko ba. Anyway, so yan. So for this one, isulat nyo lang kung ano yung nakita ninyo. For example, sample 1. So sulat nyo dyan. Red, litmus, turn to blue. Yan. Ayaw niya magpakita yan. Yan. So, ganyan ang gagawin niyo. And then, on the other side, you're going to write there, is it an acid or a base? So, sulat nyo, it's a base. Okay? So, yan. So, you complete all of the activities here. And then, afterwards, gagawin nyo yung pangalawang part nung sa simulation. So, ito yung zinc metal naman. So, for the zinc metal, you're going to pour off liquid as mentioned on the procedure. Lagay nyo to sa taas. Buksan yun. Hayaan nyo muna siya mag-bubble and then saka nyo siya sindihan. So, is it an acid or a base? So, hulaan nyo ngayon siya. Okay, so let's say it's a base nga siya. Ito yung explanation niya. Okay, so ano yung observation nyo doon? Yun ang ilalagay nyo doon sa PDF tier. Okay, and then ganun din dun sa last part. sa sodium bicarbonate. Okay? So, yan. Okay, any questions on how to navigate through the simulation? Questions? Violent reactions? Yes. Andito na yung self-activity sheet, nandun din siya sa doon sa first part, yung sa page. So for example, gusto nyo, ayaw nyo buksan muna yung PDF nyo or dalawang browser lang ang gagamitin nyo, nandun siya sa unang-unang activity natin dito. Yan. Part 3 na pala yan. Wait lang, ang tagal lang kasi. Basta nandun siya sa unang-unang part, yung sa page. Yan. Yan. Ito. Andun yung procedure niya. Tagal na. Well, I think you can answer, open this on your end, but you will see there the procedure. Okay? Pero don't worry, it's already in the PDF, andi dito pa. Any other questions? Ayan o. So, yan yung procedure. Okay? Any questions so far? Violent reactions? Doable naman, guys. Okay. Sige, Mr. Rimando, you raise your hand. Yes. Yun nga lang, medyo tricky lang po. Depende rin sa data mo. Pero alam ko kaya naman siya. Kasi natatry ko siya sa phone ko naman eh. Kaya naman siya, guys.